Hi, I'm building a Midjourney alternative and I'm getting some really amazing art coming out of it. It's called ebank.nz. It's much cheaper than Midjourney. You can generate as much art as you like. So let's build this together. It's open source and see how far we can go. So you can pick different resolutions here. Here it's doing 1080p and you give it a prompt. We'll make more kind of Midjourney-like features. We'll have different aspect ratios here. We will support some of the Midjourney commands like sref, like style reference. You can give an image here to stylize. So that's not implemented yet. We'll make it so that you can create lots of different images in bulk with different prompts. So in Midjourney, you can say like red, green, blue, and that will create three different pieces, one red, one green, one blue. So there's also a Discord channel in here. And it's very similar to Midjourney. You can type in image gen, amazing flowers, red, noise. Okay. So I'll show you how I made this Midjourney bot. It also kind of searches art so you can see what other people are creating. I'll just do a really quick walkthrough of the code, and then in another video we can go over us actually building features together. So this is all open source. It's on Stable Diffusion Server. So Stable Diffusion Server, it holds some model in memory, and that same diffusion model can do a lot of things. So it'll be able to do inpainting, style transfer, as well as this kind of Midjourney-like art generation. So here's the code. It's pretty much all in main. It's had a lot of work gone into it. So it kind of loads a SDX model here, and then here we're using latent consistency. So for that, we also load in a LoRa. That's a kind of low rank adaptation. So there's an extra AI network that's trained just the kind of important weights, and then we kind of weight those in fully, and that helps the latent consistency algorithm work well with this scheduler. So then using the same model in memory on the GPU, we can create other pipelines in Hugging Face. So you kind of wrap your model in memory in these different pipeline objects. So you've got image to image. We also have a refinement stage where you just use a different scheduler, but here it's the same model. You need to remember that the embeddings, the latent space that gets created by any diffusion model is specific to that diffusion model. So with a refiner, you should probably have a refiner that's either the same model or it's been trained to really understand the latent space of your first model. So it's kind of like the second stage in the pipeline is more careful refinement of that image in latent space. Then we've got inpainting here and a control net. The control net is something we're going to be able to do a draw tool. So you'll be able to kind of draw this castle, describe the castle, and then it will give you a lot of control over where the actual positioning of the castle goes based on your drawing. That'll help us with that. That's this control net pipeline, which is reusing this pipe as our base model. So reusing the memory. Most of this can all just be done by the same memory, the same model in memory. And we can have an extra pass after the refinement, after inpainting as well, similar to how we'll have a second pass. Yeah. So the main this is so this is, I'll show you the repository. This is the open source repo we'll be working through. It's basically a stable diffusion server a simple server that uploads to Google Cloud Storage and returns links. So that's kind of a more relaxing, better on network kind of way to serve from a CDN like Google Cloud Storage. We do use a few extra natural language processing libraries like NLTK to fix up the actual words. Maybe people can be too verbose with the prompt, and we will remove stop words, like all of the words like and or if words that aren't really going to help us. And here you can basically install the requirements and then run a server that is kind of a very, very cheat architecture. There's just a lot of retries from the client, and there's a server that's aggressively dropping any extra requests will just get dropped, and then they'll just get retried from the front end or from our Discord bot. Here we just get a request in with the prompt, or here, and we basically create a save path. We've got a width and a height, so we can create pretty much any resolution. We fix up the prompt with some kind of natural language processing inference mode. I think that makes things a bit faster. We create some an image. We use WebP, quite an efficient storage format here. And then after this all, we will upload it. So here's the main prompt here. I think we set the guidance scale in here. Oh, we should put on. Looks like we forgot this. Reminded everyone to stretch. So we have some extra arguments. Guidance scale is important when you're doing a refinement. Or this is the first pass through here, where it creates an image. After this, there's an extra pass here where it can use the refiner to refine that image in here, and it uses a bit more steps. So this is a aspect ratio preserving scale. So it scales it up and crops it. Stable diffusion can only create images with I use like a 64 by 64 kind of, it's something divisible by 64 basically, and then I use aspect ratio preserving scaling crop to get to whatever width and height we need after that. That's just I'm going to say here saves in an optimized WebP format. That can save a lot of network bandwidth by doing that. Yeah, that's pretty much it. And the next episode, we'll work on this Discord bot, which listens to commands. It can generate text, and it's the main thing that's powering this image generation command. It's fairly simple. It tells you can get similar results by searching on the website, and it will use that kind of same upload and return an image kind of logic.